Okay, this is going to be the Algebra 1 sample test for 2017-2018. This is an updated version from the sample test we had before. So we're going to graph transformations in this. Couple things that I want to explain. Well, we'll get to the number one is anchor points, the concept of an anchor. Okay. All right, so if you have an anchor, so with the function, let's just give a simple example. All right, one of the big things is figuring out where you start from, and one of the big components is whatever's on the inside, that's going to go for x, and it'll be the opposite sign, so that'll be -3. Whatever is out here will go for the y, and you'll keep that sign. So that's where you start from, -3, -4. Okay, so, and also, if you have any parent functions, all right, so for example, if you have f of x equals absolute value, okay, all right, what you're going to have is you're going to have 0, 0 as the anchor, f of x equals x squared, 0, 0 as the anchor, okay, and if you have square root of x, you'll have 0, 0 as the anchor. So when you don't have any numbers, what you're going to have is you're going to have those being zeros, okay? All right, so that should help us, especially with this first one. So for instance, the anchor point here, this is considered all outside, so that's -3, nothing on the inside, so 0, okay? All right, let me move this down a little bit. So what I'm going to do is I'm going to graph 1, 2, 3 down. So the idea here is what I want to do is I want to graph 2 x values to the right, 2 x values to the left. So if I'm at 0, I want to graph 1, 2, and then -1, -2. Okay? Okay, because those are two bigger, these are too small. So what I'm going to do is I'm going to go into my calculator, go to menu and table. All right, I'm going to type in my function. X squared minus 3. Table. Okay, I have 1. Execute, that's 1, -2. So 1 over -2 down. All right, then 2, which is 2 over 1 up. And then I got -1, execute, -1, -2. And then -2, 1. Okay. All right, and there's my graph. All right. On this one, it's all on the inside. So my anchor point would be 1, nothing on the outside, 0. The 3 does not affect the anchor point. So I'm going to start here. All right. So I got the square root function. 3, shift x squared, x minus 1. Table. All right. So what I want to try to graph, if I'm at 1, so think about like a number line. If I was at 1, 2 to 3, 0 and -1. That would represent 2x values to the right, 2x values to the left. Okay? So what I'm going to try to graph is 2. I got 2 over 3 up. 1, 2, 1, 2, 1, 2, and 3. Okay? And then I'm going to try 3. Now what happens here is I get a crazy decimal. So I want to find something that works good. 4 is still a decimal. 5, now I got something. 5 and 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. Okay? Now, when I try to graph 0, all right, it tells me error because I can't graph negative square roots. So the only thing I can graph is this. So I just connect the dots, and there I go. All right. Okay, question number 2. Okay, once again, anchor point, -1, 0, because everything's on the inside. Okay. Now, I'm at -1, so I want to graph 0 and 1, -2 and -3. We'll see how that works out. Okay? All right, so 1/5, when I make a fraction, put parentheses around your fraction. All right, to get to absolute value, I go to Option, Num, ABS, x plus 1. All right, table. All right, so if I try to graph 0, I get 0.2, which is not that great. 1, still not good. 2, no. 3, no. 4, no. 5, no. 6, no. 7, Okay, now, I don't get anything really good, so I'm going to have to take the best estimate that I can. So I'm just going to go back to 0. All right, 0 and 0.2 would be like right here. Okay, and if I do 1, it's like 0.4. Okay, it's a very flat graph. Same thing over here, -2. Okay, all right. I should be able to on 4. Why is it? Oh, 4 should be 4, 1. So 1, 2, 3, 4, 1. So it goes like this way. And then if I try it the other way, -2 is also like at 0.2. Okay, -3, -4, -5, -6, 6, 1. Okay, so it's a very flat looking absolute value. If you can get good points, use them. If you can't, you got to estimate the best you can. Okay, here's an anchor point of -4, +7. Okay, so 4 left, 1, 2, 3, 4. I'm sorry, -7. Apologize. Okay, all right. Now, let me finish this problem and I'll go back and talk about something I missed. All right, so if you go back, all right, delete, option num, ABS, x plus 4 minus 7. Okay, so if I'm at -4, what I want to look at graphing is -3 and -2, going this way, -5 and -6. Okay, so that gives me enough points. All right, so I go -3, so -3 over, 6 down, should be here. -2 is -2, -5 will be there. Okay, -5. -6 would be here, and then -6. That's what I got. Now, on each of these, I forgot to mention, you should see at the bottom, this say transformation. Okay? What I would write for transformation is 3 down for this one. That's all that happens. Okay? For this one, the transformation, I'll just write trans. All right? Transformation would be 1 right and a dilation of 3. Okay? Dilation of 3. When you have a number out in front, that's called a dilation. Okay? Same thing here. If I was writing the transformation for this, okay, I would write left 1 with a dilation of 1/5. And this one, for the transformation component, I would write 4 left, 7 down. Okay? All right, that's all you would have on that one. All right? On this one, okay, from the transformation piece, let me just do these both for transformations. We'll get the graph. Transformation, this would be 4 down, and this is a reflection. Okay, so when you have a negative number, that's going to reflect the graph. This one would be the transformation would be left 4 with a dilation of 2. Okay, so the way I would graph this, okay, is 0, -4, 4. Okay, I'm going to go to, so if I'm at 0, that's my anchor. So what I'm going to do is pretty simple. 1 this way, 2 that way, -1, -2. Okay, so I got negative, okay, table, all right. So I'm going to try to graph 1, that's 1, negative 5. 1, 1, 2, 3, 4, and 5. If I try to graph 2, crazy decimal, 3, crazy decimal, 4, reasonable, 4, negative 6. 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it goes like this. If I tried the other ones, negative 1, as you can see, has the error. This anchor point is negative 4, 0. 1, 2, 3, and 4. So what I'm going to do is I got negative 4, I'm going to graph negative 3, negative 2, and negative 5, and negative 6. Okay? So let's go back. 2x plus 4 squared. Okay, so I got negative 3, puts me at 2. Negative 2 puts me at 8. Okay, negative 5, when I type that in, will put me here just to save time on the video. Just keep typing them in. Okay, as you can see, negative 5 would give me 2. Negative 6 give me 8. Okay, this one. Okay, what I want to do is I want to take those points. That's 1, 2, 3. I got negative 3, negative 5. I've got negative 2, 0. I've got negative 1, 2, 0, 0. 1, negative 2, 2, 0. And 3, 5. Okay? So what you want to do is you want to take this and multiply this by all the y values. We're going to multiply those. So what basically happens is that y is now going to be, get rid of all the marks there. Alright? Alright? So I'm going to multiply that. Alright? So that's going to be negative 2.5, 0, 1, 0, negative 1, 0, positive 2.5. So I just regraph those points. Negative 3, 2.5 would be here. Negative 2, 0 would still be there. Negative 1, 1 would be here. 0, 0 still there. 1, negative 1 now is there. 2, 0 still there. 3, 2.5 is there. So what ends up happening is it's just a little bit shallower of a graph. This one, you take those same points. It's the same graph. And I subtract 5. So I take that and I subtract 5 otherwise. That's negative 10, negative 5, negative 3, negative 5, negative 7, negative 5, all right, 0. All right, so 3, 0 would now be here. 2, negative 5 would be there. 1, negative 7 would be there. 0, negative 5 would be here. Negative 1, negative 3 would be here. Negative 2, negative 5 would be here. 3, negative 10 would be all the way down here. So the graph does this. Shape stays the same. So that subtracted, that multiplied. Okay? This is pretty simple. This is a line. This is linear. This is square root. This is absolute value. This is quadratic. I think you guys all know that. Okay? All right. 9, pretty easy. What you want to do, this is a absolute value problem. So I start out by putting the absolute value. The anchor is 0, negative 2. So I'd have a negative 2 out here. What I need to do is get this number out front. What I do is I count 1 right of the anchor, and I go up to how much until it hits my shape. So I count 1 right, 1, 2 till it hits the shape, so a 2 goes out front. Okay? This one is y equals square root of x. That's 1, 2, 3, 4. So it's negative 4, 0. So that's x plus 4. Now, if I go 1 to the right, 1 up, it's a 1. You can just leave it as it is. Okay? Moving on. 0 is x intercepts. This crosses at negative 1 and negative 3. So it's x equals negative 1, x equals negative 3. X-intercepts are the same thing as 0, so we're not going to overcomplicate it. The y-intercept is where it crosses the y-axis, 1, 2, 3. That's y equals -3. Okay? So that's the y-intercept right there. All right? Now this one, okay, what you're going to want to do is you're going to want to graph it. Okay? So my anchor is -2, -1. All right? And I'm going to go x plus 2 squared minus 1. So I want to graph -1, which is 0, and 0, which is 3, and -3, which is 0, and -4, which is up at 3. Okay? So then I go ahead and I graph that. All right? So it crosses at -1 and -3. All right? My y-intercept is 1, 2, 3 up. So it's just going to be y equals 3. Okay? End behaviors. We go ahead and label our arrows. This is a left arrow, so it's -infinity. This is a positive arrow because it's the right side. This is going up. This is going up, so they're both positive infinities. This coordinate is 1, 1, 2, 3, -4. So when I do increasing, decreasing, I start from here. So that goes down, so that's decrease. So always start from your left. I hit that, that goes up, it's an increase. Now, all I care about are those x values. Okay? So what I got here for an increase is 1 to infinity. Here, I go from -infinity to 1. Okay? All right? All this says is find the x coordinate that's infinity. Okay? The y means what's its y. Okay? So I look at that y is infinity. I look at that y is also infinity. Okay? Okay, for 14, you're going to want to graph it. Okay? The announcements are going to come on, but what you should do are, the anchor point's 5, 0. So 1, 2, 3, 4, and 5. Okay? All right? And then what's going to happen, just if you go to plot it, it's going to look something like this. All right? You plot the graph out. Use the table. Okay? So when I label this one, this is -infinity, negative. Left going down. Right, that's positive with -infinity there. I label this as 5, 0. All right? So this is my increase. I'm going down that way, that's decrease. So it's increasing from -infinity to 5, because I care about the x's only. And then it's decreasing from 5 to infinity. Both of these answers are -infinity. Okay? Moving on to 15. Domain and range. There's my arrow here. That would be positive, positive. This would be -2, 0. So what I want to look at here is what's my smallest x value. Okay? Now, here's something you should know. Let's say we had 5. If we shaded this way, old school Algebra 1, this would be x is greater than or equal to 5. What does this mean? It means it's going on forever in the positive infinity direction. If I was going the other way, shading, that would be going towards the -infinity. And I would write x is less than or equal to -5. Okay? So keep this in mind. You might want to write this down when you get your test because it will help you. Because my smallest x value here is -2. My biggest is infinity. So I have this scenario. So I have x is greater than or equal to -2. On this one, on the range, so this is the x, on the range the smallest y value is 0, the biggest is infinity, so I still have this relationship, y is greater than or equal to 0. Okay? On this one, all right, this would be infinity, infinity. This would be -infinity, positive infinity. Okay? I think that's 1, 2, 3, 4. It's hard for me to tell. Let's just make that 4, negative 3. Okay, so my smallest x value on this is negative infinity. My biggest x value is positive, so I'm going to have domain is all real numbers, XER. For the range, my smallest y value is negative 3. My biggest is infinity. Once again, this scenario. Now, range is y. So y is greater than or equal to negative 3. Okay? Graph this one if you want. Okay? What I would do, x squared minus 3. All right? Your anchor point is 0, negative 3. So if you graph 1, it's at negative 2. You graph 2, it's at 1. If you graph negative 1, it's at negative 2. And negative 2, it's going to be at 1. So here's what your graph looks like. This, boom, that, like that. Okay? So once again, that's negative infinity positive. Okay, that's positive, positive. Okay? Left arrow going up, right arrow going up. This is 0, negative 3. Smallest x values is negative infinity. Biggest is positive. So that's x is all real numbers. My range for my y's, my smallest y value is negative 3. My biggest is infinity. Once again, I've got that going on where it's greater than or equal to. This one, my anchor point is negative 4, negative 3. 1, 2, 3, 4, 1, 2, and 3. Okay? Then I go into the calculator. Okay? Option num ABS, x plus 4 minus 3. So I'm going to graph negative 3, which puts me at negative 4. I'm going to graph negative 2, which puts me at negative 5. I'm going to graph negative 5, which puts me at negative 4. And negative 6, which puts me at negative 5. So this is what I got. That's my graph. That's negative 4, negative 3. This would be positive infinity, negative. And this would be negative infinity as well. Okay? So my smallest x value is negative infinity. Biggest is infinity. So that's all real numbers. My y values, my smallest y value is negative infinity. My biggest is negative 3. So if you go back to this, I've got this scenario. I've got the less than scenario. All right? So y is less than or equal to negative 3. Okay? All right? And this has been covered. Okay? Circle all the following that have a range of greater than or equal to negative 2. What you're looking for are anchor points. That's a line. And lines are going to be all real numbers for that, so that's out. The only two possibilities are here and here based on the anchor point. Okay? This says describe in words. Okay, what would happen with this? Okay? Alright, is you would subtract 2 from x's, multiply the y's by 3. Okay? This one I would add 4 to the x's compared to this one where I would subtract 4 from the y's. Okay? State the domain and range. What you want to do is plot this. So 1, 2, 3, 1, 2, 3, 1, 2, 3. That's negative 3, negative 3. This is 1, 2, 3, 4. This is 1, 4. This is 1, 2, 3, 4, 4, 2. So when I'm doing domain, smallest x value, negative 3. And since it's in a closed circle, we'll have that. My biggest is 4. And since it's an open circle, it has that. Range, smallest y value is negative 3. Has that because it's closed circle. Biggest one is 4 up here. Okay, so that would be like that. This one, I got to label the arrows. This is negative infinity, negative infinity. This is positive infinity, positive infinity. I think this graph was supposed to be shifted over, okay? So we won't worry about it. This one I'm supposed to label 1, 2, that's 2, 1. This is 1, 2, 3, 4, 5, 0, 5. This is negative 2, 2. Okay? So if I'm doing domain, the smallest x value is this, the biggest one. I'm not sure if they want you to do this, but it would be all real numbers. Okay? But I think the only ones that it's between -2 and 2. We're not talking about lack of continuity. This should be probably over here. I'm just going to show you briefly. Range, the smallest y, that would also be all real numbers. Okay? Based on the picture. All right? There would be discontinuity. Not here because it would cover all of it. The domain might be, you have to ask your teacher about that. Increasing and decreasing. Okay, I start here. There's my increase. There's the decrease. There's the increase. So I'm increasing from -infinity to -2. I'm decreasing from 0 to 2. That's all I care about is the x's. And then I'm increasing from 2 to infinity. I think that's the video. Okay? So if you go through that, you should do pretty well. Just practice some of those skills.